So this is the BYD Shark 6. I'm at the Australian media launch, and in this video we're going to be doing a detailed explanation of what the Shark 6 is, how it works, and looking at whether it's right for you. So to introduce the BYD Shark, it is a new ute to the Australian market, but also one into a new market segment which didn't exist before it arrived. It is a PHEV or plug-in hybrid electric vehicle ute, and I'm going to explain what that means in a moment. It is all-wheel drive, but it does have some off-road capability. And it is what's known as a series hybrid, so it has just one gear, there's no gearbox in it. The manufacturer is BYD, who only make electric and hybrid vehicles, and this is their first ute slash four-wheel drive. Now I want to stress that the vehicles we had were 3 pre-production versions, so there will be some changes to production, although probably quite minor, and we only had about 2 hours to do what we needed to do with them, which isn't very much. That's typical on a press launch, and you cannot possibly evaluate a vehicle as complex as a new PHEV ute in that period of time. So I do have a blog post to support this video. Go there for comments, clarifications, and any information which comes to light after this video is published. Let's compare Shark to Ranger. Now the Ranger specs will vary depending on which variant of Ranger you're looking at, but they are pretty much the same length and pretty much the same width as well. Specs are a bit different. The Shark is quite heavy at 2,700 kilograms and its GVM is 3,500. We'll cover weights in a moment, but that gives it quite a low payload for a ute of not even 800 kilograms, and it can only tow 2,500, whereas the Ranger typically has a payload of around about 1,000 and it can tow 3,500, although there's a bit more to both towing figures, which we'll get to later on. Now, let's also talk about what a hybrid is, because this is a really complex subject. I'm not going to go through every possible combination here, but I will give you enough of an overview to understand what the Shark is and its pros and its cons. We're going to start with an ICE, internal combustion engine, which is effectively either a petrol or a diesel engine. And we've got 4 wheels here. We're going to take our engine, we're going to put it through a gearbox, and in the case of the full drive, a transfer case, run a shaft to the back, a differential axle that drives the rear wheels. We'll do the same at the front, and therefore we've got that engine driving all 4 wheels. Now let's take a look at the other extreme, which is a BEV or a battery electric vehicle. Again, we've got our axles and we've got our differentials. This time though, we're just going to put an electric motor on the back, an electric motor on the front, and a battery, connect them up, and then off we go. Now we can also put a motor at each wheel. That's individual wheel drive. I've explained that in other videos, but for the purposes of this video I'm going to keep it relatively simple. Okay, now the only battery source for a BEV is the battery, and that's it. And whilst I've shown this as all-wheel drive, it could drive just the front or just the rear. You can get front or rear or all-wheel drive BEVs in the same way you can from ICE vehicles. Now, what's a hybrid? Well, the simple definition of a hybrid is it's both ICE and EV, and that's a HEV, yet another acronym. HEV is hybrid electric vehicle. So let's just take exactly what we've got over here, except we'll just make it front wheel drive. So we've got our petrol engine or diesel engine driving the front wheels. Many cars have that configuration. How do we make it hybrid? Well, we just add an electric motor typically onto that same prop shaft, and that electric motor helps turn the prop shaft, and it's connected to a battery. That's literally it. That is your basic hybrid. Now, what I should say, that's a front wheel drive hybrid. We could make it an all-wheel drive, or we could make it a rear wheel drive. Now, this is typically how a rear drive hybrid is made. We take that exact same configuration and we just put an electric motor and diff on the back, and then we can drive the rear axle, and then the front and the rear motors are kept in sync, not with a prop shaft but with software, and that's a concept I call a software powertrain. There's other ways to do all-wheel drive hybrids. That's just one example, but the important point is that the power source is battery and ICE, and it can drive front, rear or all wheels. That's all a hybrid is, 2 power sources. There's a couple more types of hybrid to understand. The first one is a parallel hybrid, which is what I've described so far, and the important thing to understand there, there's 3 ways those wheels can be driven. One is ICE only, so that's the petrol or diesel engine directly turning the wheels. 2 is electric only, and 3 is both of them combined together. That is your parallel hybrid. Then a series hybrid is what we're going to look at next, and here we have an ICE engine, but the ICE engine never drives the wheels directly. It either acts as a generator to generate electricity directly for the electric motors, or it can also charge the battery. And in this case, the ICE engine can also charge the battery as well as drive the wheels, and it's constantly changing what it does. Either it will drive the battery, drive the wheels, or both. Whereas series hybrid, it only ever charges the battery and acting as a generator. Now, both of these vehicles can charge on something called regen. So when a hybrid slows down, the electric motors change from being motors to generators, and then they generate electricity which goes into the battery and is stored. So that's a harvesting energy. So if you're at the top of a hill in a hybrid and you drive down, you'll actually charge the battery simply by turning those electric motors into generators. Okay, so this is the last one before we get into it, but it's important to understand this stuff so you get where the Shark is actually coming from. So a normal hybrid is what I've described, and it's got a small battery, maybe the electric range only 2 or 5 kilometers. Now this could be, and I put here a parallel, but it could also be a series like the Nissan e-Power. The battery is only charged by the ICE and regen. You cannot charge it externally, you can't plug it in, and essentially the electric systems there are designed to aid the ICE and kind of extend the range and get better fuel efficiency. It's not really designed to be driven only on electric mode, although if you're parking the car or crawling around a campsite or something like that, it will typically go to electric mode, but you won't really get very far, maybe 2 or 5 k's on pure electric mode, and typically not above 60, 70 k's an hour. Then we've got the PHEV, or plug-in electric hybrid, and that's what the Shark is. This is different. Now you can see here the difference between the two concepts is this is a small battery and that's a bigger battery, and the other difference is that you can plug in and externally charge that battery. So we've got a larger battery here, and we might get an EV range typically on or 30 to 100 kilometers an hour, and it typically won't be speed limited either. So the idea is you can make short trips purely on electric. The battery again can be charged by the ICE engine or by regen, but also externally as well. And effectively the difference between a PHEV and a normal hybrid is that the PHEV is designed to run on electric mode only for short trips, 30 to 100k, depending on how big that battery is. So what is the Shark? Well, it's a series hybrid. So, and this is not how it's laid out, but conceptually we've got an ICE engine, that's a 1.5 litre turbo, and that will effectively generate electricity for the battery. The battery is connected to a motor at the back and a motor at the front, electric motors, and that's how it is set up. Now there's one kicker with this, which is above about 70 kilometers an hour, depends on the conditions. Then the petrol engine will actually drive directly the front axle, and it does that by engaging a clutch. There's no gearbox, there's no torque converter, it's just a clutch in and out, and that's why it has to come in at 70 k's an hour, because there isn't a gearbox or anything else there. So that's what the Shark 6 is. You can think of it as a series hybrid. It's not technically a series hybrid because we do have that direct drive in some circumstances, but think of it as a series hybrid PHEV. So this is an accurate diagram of what the Shark is. At the front we've got the 1.5 litre petrol engine, then we've got the battery nice low and centre in the middle, we've got the front electric motor over here, the rear electric motor over there, and then over here we've got a 60 litre petrol tank. Now let's compare that to a Range Rover Sport, which is also a PHEV in some variants, and over here we've got a battery. Now the difference with the Range Rover Sport and the Shark was that this is not optimized from the ground up as a PHEV. You can see we've got this drive shaft here, so we can't put that battery in the middle, and the battery's got to go at the back, so it's poor weight distribution. It actually loses the spare on this as well. We do have an electric motor here, so that's a parallel hybrid. That electric motor just turns the same drive shaft in effect as the petrol engine, and that's the large petrol engine at the front. So quite a different architecture there. And let's just contrast the two. one advantage of the BYD, it's a ground up design. So right from the start, the BYD engineers were designing this for hybrid, whereas with the Range Rover and most other hybrids, they've sort of tacked on the hybrid after the fact. And you can see the difference here. Look at where the battery is, the space they've made for it here versus there's no space there, for example. A much smaller engine because they are going to be relying on those electric motors, whereas you've only got room for a small electric motor here. So, it's just much better to do a ground up design. You can have the chassis design completely for it. You can have the ideal placement for performance. You want that heavy battery central and low as opposed to at the back and relatively high up, and there's just minimal wasted space. So that's the advantage, and this goes for electric vehicles as well as hybrids as well. Ground up design's always better than just tacking it onto an old ICE design. Over here on the steering wheel we've got mode, and mode is sport, normal, eco. That's your on-road modes. So leave it at normal. And then this one over here is the terrain modes, and the terrain modes are mountain, muddy land as opposed to muddy sea, sand land as opposed to sand water, snow, and back to mountain again. And if you want to switch back to a road mode, you just select one of them here like so, and then you can select your road modes, and each of them recalibrates the car's electronic systems. Okay, that was the theory. Now for the practice. We're going to take a look at the Shark accelerating in different modes, which will allow us to look at the front-rear torque split and also the effect of different driving modes and stability control and traction control calibration. So let's replay that in slow-mo. You can see that there's considerably more wheel spin at the front than the rear, which is not good news. They should be biasing torque towards the rear because that is where the load shift is, that is where the grip is, so that's not good to see. You can see that in normal mode, the amount of slip is not optimal because there's more wheel spin, yet the car gets away quicker with ESC off. Now this is what you'd expect. Normal mode isn't necessarily your gravel driving mode, but it's interesting to see the differences. Now this is the car with its sport mode on, and that clearly relaxes the stability control a little bit, and as a result it makes no difference to the acceleration whether the stability control is on or off, because with it on in sport mode it's controlling slip at kind of the optimal rate for this particular acceleration test in these particular conditions. However, unfortunately we still see that front drive torque bias, which is not ideal. And here's the vehicle in its gravel mode, and you see it's actually going to accelerate identically, but it gets there in two different ways. With the ESC off, it allows more wheel slip, but that doesn't actually do the vehicle any good because the ESC on in gravel mode actually has the same result. You can see the amount of dust being kicked up is different, but the car's accelerating at the same speed. So good job on the gravel mode there in that particular test. Now let's talk about the all-wheel drive system, and BYD are describing, one might even say bragging about it here. They call it intelligent all-wheel drive and virtual energy distribution. Well, what does that mean? Well, they described it in a conventional vehicle when you have in a cross-axle situation or something, all of the power can be directed to a slipping wheel and just spin. Well, that's incorrect. We've had brake traction control for well over 20 years, 25 years now, so that is incorrect. And they're saying that with a diff lock engaged, each wheel will receive exactly 50% of the available torque. No, when you've got a diff lock engaged, one wheel can receive all the available torque. That's literally what a diff lock does. It's when you've got an open diff, you always get a 50-50 split. So they talk up how good that is. So let's see how that works in practice. But before we do that, we need to talk about three types of traction control. And the first one is brake traction control. This is when a vehicle has a wheel which is spinning, cross-axle, that wheel is braked, as I've put here, and then torque or drive force is sent to the other wheel, you can move on. Then we've got engine traction control. This is when the engine computers say, hang on, we've got multiple wheels spinning here, we need to reduce the engine torque or power to manageable levels to keep everybody safe. And then we've got ESC, or electronic stability control, and this is when you hook into a corner, you're going left or round a corner, say, and the car might plough on off the road, or the back end might step out, and it will individually brake each wheel and even reduce the throttle and various other things to keep you going around the corner the way that you want to be going around the corner, as opposed to spearing off the road. Now, in off-road terms, this is good. You always want that enabled. This is bad. You always want that disabled. And this is also bad. You also want that disabled when you're into rough terrain. Do not confuse the three. I've got another video where I demonstrate and explain this in more detail. Now let's put the Shark through a cross-axle situation to test its traction control. So we're going to get to the point here where the wheels is just spinning, and let's see what happens. You can see that there's tyre smoke coming up. We're not getting torque to that front left wheel at all, nor to the rear right. Eventually it wakes up and we manage to drive through. Now this is in normal mode. This is not the ideal mode for this sort of terrain, but a typical four-wheel drive would be able to handle this with a lot more drama than what we see here at the moment. Now this is that same run from another angle, and what we find here is that neither rear wheel is moving, but only the front right wheel is spinning. So that's equivalent of having open diffs with an open centre diff. This is not what we should have, and that's what I mean by the vehicle tends to be front biased as opposed to rear biased. Now we're going to put it into its mountain/gravel mode. Normally gravel mode is for high-speed dirt roads, but anyway, and you can see here that again we're getting a bit of wheel spin, but it's not as bad as it was before, and after a bit the vehicle does pull itself forwards up this part. And then here's the other part where it gets cross-axled. Again, there's a bit of slip, but at least we're getting some drive to the rear axle now. That's something, and the brake traction control is working. So the mountain gravel mode did work a bit better. And here's that same run again, but from a different view. Third time up, and we're going to be using mud mode this time, and typically mud mode should work quite well in these sort of situations. There's not a huge difference to the mountain gravel mode that we can see, maybe a bit more spin, but it's certainly a lot better than normal. We are getting some torque to the rear axle, which is good. Now here's sand mode. Now sand mode shouldn't work because it's typically designed for high revs and loose traction surfaces, and the traction control shouldn't work that well, but somehow, for some reason, sand mode actually works the best out of all the modes, which is weird and bizarre, but here we are. Just look at it, it's absolutely minimal wheel spin compared to the other modes, and I think we figured out later on why that is. But for the moment, let's just take a look at that from a different angle. And this is snow mode. Now snow mode shouldn't work. It should be for generally for icy conditions, but you know, this is BYD, things work differently, so let's see how it goes. And the answer is not well at all, which I'm okay with because it's really not designed for this. The only reason we're testing it is because it may or may not work. I mean, sand mode worked really well, who knows what happened with snow mode. But here's the problem, it's not learning. I can understand a slow response, but the computers should figure out, hey, we're not going anywhere, we've got wheels massively spinning, let's do something about this. This is how brake traction control systems work on other vehicles. Look at my videos on Land Rover's systems, for example. It's just sitting there, it's not figuring out what's going wrong, it's not sending torque to that front, left or right wheel. Eventually it does. So again, the software calibration off-road of the BYD Shark leaves a lot to be desired at this point, I'm afraid. And here's a split screen, so you can see normal, mountain gravel versus sand. So I think sand is the one to drive in. Normal, it should perform better than what it's doing here at the moment, because the electronics should figure out what's going on. And mountain gravel, yeah, I'm surprised that doesn't perform as well as sand. Now here's a couple of clips which clearly show that there is, in some cases, no torque, no drive going to the either rear wheel, and the front right is just spinning, and that should not be the case. So that's a real problem. If only it could get some torque to the rear axle, it could actually pull itself out of that. So here's another example. This one's actually in normal mode. You can see quite clearly there, front right spinning, and nothing else is going on. Now, after the test was complete, I went to get my Ranger, put it over the same obstacle so we could compare. The Ranger is 4 generations old. It's a PX. It does have all-terrain tyres, but it's really more about torque distribution than anything else. It does have poor brake traction control. So you can see that the BYD Shark doesn't do too badly against it, but by 2024 standards, it's not ideal. What we've learnt is there's the ESC off button. Now if I'm in normal mode, okay, then ESC is on, which means the button is not illuminated. Okay, and now if I select snow, you see that ESC is on, and then if I select mountain, ESC is on. And if I select muddy, it's on, and if I select sand, it's off. Right, so that's already the reason why sand mode works the best, because it has ESC off already. So we decided to try mountain mode with ESC off, but before we do that, let's try it with ESC on so that we've got a point of reference. Okay, now ESC off, and the results are quite impressive. So that was unexpected. Looks like it completely disables not only ESC but also brake traction control, and because of the effects on the vehicle we only tried it once, so I'd recommend never ever switch ESC off, just use sand mode. Okay, to finish off, we'll put the vehicle into sand mode and drive it with the proper amount of momentum. You can see it's actually quite capable, but we have explored what to do and what not to do with the electronics. So that's part one. In the next part, we're going to be looking in and around the vehicle. I'm going to give you some driving impressions on and off-road. We're going to look at towing and weight specification analysis to see how much it can really tow. Doing more off-road driving analysis and accessories. We're going to take a look at the PHEV mode for not just transportation but also potentially for camping as well, and also ask whether the Shark is right for you. And if there's any common themes out of the comments on this video, I'll address them in the next ones as well. I hope you found this video useful. If you've got any questions, please use the comment section.